Welcome. This is a screencast of the presentation on Common Core State Standards 101, put on by Liz Larson, a Common Core site coach at Poly High School, and Sarah Longa, the District 712 Math Staff Developer for Riverside Unified School District. In this session, teachers will learn how to navigate, reference, and use the state-adopted standards to support classroom instruction and recognize the level of student application upon course completion. In 2014-15, California state standards shift from those that we have had since 1997 to the new California Common Core state standards. We joined many other states in the U.S. in teaching these Common Core standards, along with some additions that California added. The shift to these new standards does bring about some change. One obvious change is that the math standards have been broken up into two areas now. We have our traditional content standards that we had in 1997 with verbiage change and shifts in the content. And then we also have an additional set of standards called the Standards for Mathematical Practices. These SMPs are across all grade levels K through 12 and are practices and habits to helping form a mathematical thinker. Parents and students will be naturally inquisitive about the shift that is taking place. This session goes over the shift from 1997 to the Common Core State Standards. In dealing with parents and students, please be aware that our district does have information about Common Core on their website. If you click the link down here to RUSD Math, it will take you to our district's webpage. On the very front of the webpage, there is a yellow box that says, "What is Common Core?" On it, it's a district website with information, pamphlets, and videos that parents and students can use. So as a teacher, you want to make sure you informed yourself about what parents and students have access to. Let's look at the standards. Here are the standards for mathematical practice. We call them SMP for short. These are practices to incorporate throughout the year and at each grade level, and stay the same throughout all grade levels. These SMPs are actively in the classroom, and it's wise to weave them into your lessons and planning on a daily basis. Here are 8 listed ways that some teachers have begun to implement the SMPs in their classroom. Take a moment and match each phrase with an SMP. Pause the video if you need to. Here are the answers. Did you get them right? Now, the content standards are arranged by domain and cluster. Domains are large groups of related standards. Domains change from grade to grade to reflect the changing focus of each grade. Clusters are bolded groups of related standards. Each domain has 1 to 4 clusters. Standards define what students should understand and be able to do, and they are numbered. If you go into the presentation and if you click on this link or onto the Haiku page, you'll see the California State Content Standards are available, as well as a SMP document as well for the Standards for Mathematical Practice. Now that we've seen those content standards, let's look at a set of standards specifically. There is a definite shift in the language of the standards. The 97 standards were more about how can I teach my student to get the answer to a problem. A much more algorithmic approach. I'm going to teach you how to do things this year, and then you'll move on to the next grade level. The Common Core standards use problems to teach the mathematics. There is a definite shift in word choice. 97 standards are much more on an approach, a way to do the problems. Now the standards use more verbs. As we look at this sample here from 97, on the left-hand side is a 97 standard about students simplify expressions before solving linear equations and inequalities in one variable. Over here, if we look at the Common Core standards, it's not simply about simplifying and doing the math, but it's really on understanding the math. So they are supposed to interpret expressions that represent a quantity in terms of its context, and interpret the parts of an expression, such as terms, factors, and coefficients. And they are to create equations and inequalities in one variable, including ones with absolute value, and use them to solve problems. So it's not about just simplifying and solving. It's really about understanding the mathematics that is going on. So you can see a definite shift in the verbs. There is a little bit of a shift in terms of how the standards are organized and in the instruction of the standards. These three specific shifts you've probably heard already are focus, coherence, and rigor. The math standards, especially at the K-8 level, have a strong adherence to focus, coherence, and rigor. Some of these shifts exist in high school, but may not be as noticeable as they are at the K-8 level. So let's look at each one a little closer. Shift number 1, focus. Focus is spending more time on fewer things at each grade level. So if you're reading this and you're thinking, I'm teaching Math 1, and there are a lot of standards and it really doesn't look any smaller, remember this focus really does, especially at the K-8 level, it exists, and to some degree at the high school level, with these things called critical areas. Every year has critical areas, and these are concepts which demand the most time, attention, and energy throughout the school year. They're not just a checklist to be done with, but rather recurring throughout the year. So these main critical areas, these focuses for the year. And what writing teams did in our district was they first read the critical areas and built the units of study for the entire year based on those critical areas that are in the standards. So it's time for a pop quiz. Classify the following 5 critical areas. So we took a critical area from each grade level, 7th grade, 8th grade, Math 1, Math 2, Math 3. We'd like you just to try and see if you can think of which one belongs in which year. Which one is a critical area for each year. So go ahead, pause the video, or just take a moment to figure it out. Write down what you think. And here are the answers. That first slide, 7th grade math, drawing inferences about population based on samples. That third green box, apply methods from probability and statistics, draw inferences about conclusions, and conclusions from data, is a Math 3. You got that right, hopefully. And so now we're going to take a moment to select a year and do just like the writing team did. Read those critical areas. All the critical areas are in the haiku class. And so take a moment, read the entire year, pick a year that you're teaching, and then as you're reading this, kind of mark up the text with what you do know, with a check mark, what you feel you are not totally sure about what they're talking about, with a question mark, and kind of pay attention to what has been taken out from the year and what has been added to the year. And then think to yourself, how do these critical areas shift instruction in the classroom? Once you've done that reading and that think, find a colleague at school, or if you're doing this in a group setting, work in pairs to share out what you see, what you notice. All right? All right, that second shift we call coherence. We're thinking across grades, where we carefully connect the learning across grades so that students can build new understanding on foundations built in previous years. So typically, a current math year spends about like 25% of the year reviewing and reteaching previous grade level standards, but not as an extension, but rather as a reteaching exercise to get them ready for the year. Coherence allows for the review and reteaching of previous standards to naturally build within the year. So it begins to count on solid conceptual understanding of core content, and then we build on it. Each standard is not a new event, but an extension of a previous year. Here's a sample pathway of a topic that crosses grade levels. So we're talking about proportional reasoning in middle school. In 6th grade, they start to talk about unit rates and get exposure to unit rates with whole numbers. In 7th grade, they then approach 2 standards where they're recognizing and representing proportional relationships between quantities. And then in 7th grade, they're also starting to explain what a point on a graph of a proportional relationship looks like. And then they transition into 8th grade where they're graphing proportional relationships and interpreting the unit rate as the slope of the graph and comparing proportional rates represented in different ways. So they really are, over those years, really expanding on that knowledge of proportional reasoning. Here's a high school example. We begin to talk about rigid motion, those transformations, in 8th grade, where students kind of play with them. They work on physical models, moving and understanding congruence and similarity. And then in the high school, they really start to use use transformations, rigid motion, to prove congruence about shapes and build those in. And then in Math 2, the last standard there, SRT 5, is a Math 2 standard where they're using congruence and similarity to solve problems and prove relationships in geometric figures. So they extend it not just to congruence, but then into similarity and using it to prove and to solve problems as well. So it extends across several grade levels. We paid attention in the writing teams to this idea of coherence by within each unit of study, there's an area on the very first page called the unit of overview. So this unit overview talks about where the students previously, where were they previously, what are they going to do in that unit, and where are they heading. So here's a sample overview. That first sentence is talking about where they are, where they've come from. The next sentence is talking about what they're going to do in that unit, and the last sentence is talking about where they plan to be in the next coming year. So take a moment, reflect on what you think the benefits to having coherence in the Common Core standards would be, and find a colleague to discuss with at your school site. If you don't have a colleague at your school site, then feel free to discuss with if you're in groups, maybe find your department chair or something like that to discuss this with. The third instructional shift is rigor. Rigor in the mathematics classroom includes conceptual understanding, procedural fluency, and application and problem solving. Each one requires an equal amount of time, activities, and resources. It's like a braid interwoven together in the classroom. And you're weaving in and out of conceptual understanding, procedural fluency, application, and problem solving. And there's never one that's overpowering either one of the two. For example, what the writing teams did to approach rigor was while developing the sample unit assessments, the writing teams coded the level of questioning for DOK, as well as what component of rigor was being assessed. So here's a sample pulled from the 7th grade Unit 1 sample assessment. So you could see, in terms of rigor, they made sure we kind of had an equal amount of point values, a little bit, to each of the 3 areas of rigor. So let's examine each area of rigor briefly, as we'd like them all 3 areas of rigor to be in our classroom, in our practices, and in our assessments. First, solid conceptual understanding. Students are able to see math as more than a set of mnemonics or discrete procedures. They can see how things are tied together, and they can easily flow between concepts and ideas. So I like this visual here to explain conceptual understanding, as students are able to fluently navigate from various forms of a mathematical situation. They feel comfortable transferring from verbal to pictorial to symbolic to concrete. They really understand what they're doing, and they are not confused or concerned when they see a question or situation in a different format. They're comfortable and feel good in what they know. Procedural fluency is when the standards require speed and accuracy in calculation. Teachers should structure class time and or homework time for students to practice core functions. It's not simply memorization, absent of understanding. The procedural fluency flows well with understanding. Some students might require more practice than others, and that should be attended to. Additionally, there's not one approach to get to speed and accuracy that will work for all students. All students, however, will need to feel comfortable and find a way to develop speed and accuracy in their calculations. Using mathematics in problem-solving context is the third component of rigor. Students can use appropriate concepts and procedures for application, even when not prompted to do so. Sometimes we feel like when we hear the word application, we think real world. It is good to provide them real world opportunities, but the other side to the application problems is that in the questioning about the problem, we're not prompting them in our wording to have them use a certain method or a certain style or a certain procedure. We give them a question and they figure out how to do it. This is the kind of the why we learn math piece. We learn it so we can apply it in situations that require mathematical knowledge. We want students to be problem solvers, to be avid math thinkers. There are requirements for application all the way throughout the grades in Common Core. But again, we can't just focus solely on application. We need to also give students opportunities to gain deep insight into the mathematical concepts and gain that conceptual understanding they are using, and also develop fluency with the procedures that will be applied in these situations. The problem-solving aspect of application is what's at stake. If we attempt this without a lack of conceptual knowledge and procedural fluency, the problems just become very hard. At the same time, we don't want to save all the application for the end of the learning progression. Application problems can be motivational and interesting, and there is a need for students at all levels to connect the math they are learning to the world around them. Now here's an activity. You're going to click on the link called Ivy Smith Grows Up. This is a performance task, and with the following performance tasks, determine what parts of the questions are conceptual, procedural, and application. So you're going to act like a writing team member and kind of classify those questions as, is it a conceptual question we're asking, a procedural question we're asking, or is it an application question we're asking? So you'd want to pause the video and do that activity. One final note, when implementing Common Core, it's not a compartmentalized, sterile, algorithmic approach. Instead, it's a very integrated approach where we're weaving the best that we have and building that mathematical mind in students. Thank you.